بسم الله الرحمن الرحيم رب زدني علما.
So let's try to see the remote access using SSH. Now we already discussed SSH is more preferable over Telnet. Now the reason is SSH connections will be encrypted. So which means whatever the connection, once you establish the connection, whatever the commands you type in or whatever the login information you type in, whatever the identities or passwords or the data, anything, they are all encrypted. So the advantage is it will protect your information or identities or the passwords from any kind of snooping attacks, because the attacker can actually snoop in or capture your packets, which will where there is a vulnerability with your telnet. Because if attacker captures your packets, he can clearly see the username and the passwords or whatever the commands you actually type in on the remote device. So we always prefer to use SSH, the secure shell, which provides a secure alternative to your telnet, because the telnet simply transfers the data in a clear text. We already discussed that. Now, again, in terms of configuration, it's more similar to what we generally do on the iOS routers. So the first step, we need to create a username and the password. And this username and the password will be used for login. So we need to create one user account. Preferable, you create with a privilege level of 15. Privilege level 15 is a default, means highest privilege levels. So the first step, we need to create one user account. And this user account can be used for login as well. The best practice, you create one user account with admin with the highest privilege levels, 15, so that anytime you want to make any changes, you use this account. Of course, you can add multiple user accounts as well. Now, the next step, we need to create something called SSH key pair. Now, the key pair is important because we said that the connection will be encrypted. So in order for the encryption to work, there must be some kind of keys involved. And here we call them as a key pair, SSH key pair, we call it as. And this key pair will be used for authentication of the identity for a specific user or whatever the connection you established, accessing remotely. And there will be some kind of public key, private key combinations, which will be used to encrypt the messages which are going between them. So generally creating a key pair, nothing but we need to add this command called crypto key RSA, generate RSA. That is, once you add this command, it's going to create a key pair, which will be used for encrypting your sessions or encrypting your connections. So the same thing, you need to do it on the iOS as well. And after that, we need to configure the user to use a local database for authentication. So I need to specifically say that AAA authentication, if someone tries to connect through SSH, previously we used Telnet. Now this time I'm using SSH. Then it has to use the local authentication. You can also define any remote servers if you configure. So we're not getting into that right now. We are using the local authentication. Make sure that this local is capital letter, because it refers to the local user account, not refers to any other servers. If I use small letters, then basically it refers to any other external servers. And then I'm going to tell that SSH connection should be accepted from which interface you want to allow and from which subnet you want to allow. So here I'm just allowing for everyone, but it can be more specific here. So this is a kind of set of configurations you need to add on the ASA for these things to work. So on the ASA, the first thing, let's verify the user account. Already I have a user account created, so I can still go ahead and use the same user account. And you can see it's encrypted, but the password is NY123. And we need to create a crypto key pair. There is something called crypto key we need to generate. By using which algorithm? We generally use RSA algorithms. You can press enter here, or you can just say modules, where you can define how many bits of key you want to generate. You can also define that. There are some additional parameters you can add. You have an RSA key already defined. Do you want to replace this? Yes, I want to replace. So now this will create a key pair which is used for encryption, authentication, as well as your encryptions. And then we need to tell authentication should be enabled for SSH, and then it should be enabled for local. You can see the local keyword we need to specify if I'm using the local server in capitals. And then we need to tell SSH should be enabled from which subnet. So I can be more specific. I can even say a specific subnet, let's say 2.2.2.2. It should be allowed for this IP only. I'll also check the routing, okay? And from which interface, inside or outside, we can specify. So generally, again, this will be not outside because you never want anyone from the outside to SSH to your ASA. That's something you don't do. Typically, this will be your management interface. Again, you connect to the management interface and you want the SSH or telnet should be allowed only to your management interfaces and not to your inside and the outside interfaces. If you remember, we discussed out-of-band management. We always want to keep separate your inside and outside interfaces, which are pure dedicated interface for sending and receiving your data. Whereas you want to use a dedicated management interface for your management related purposes. But here in my lab, I'm not creating any separate interface, but you can just go ahead and add one more interface and add that as a management and security level of 100. And you can just test your telnet connections, SSH connections from that subnet. That's something recommended. In my case, I'm just going with my existing topology. And let's go and verify. So now I can go back to my router 2 to initiate the connections. So let's get back to our router 2 to verify here. So in general, you can also do it from verify from the PC. I don't have the PC connected here. So which means from the router 2, I can initiate a connection called SSH -L. L is I'm saying user account. Whatever the username you have to specify. And then what is the IP address of the device, the ASA 20.10. And of course, SSH, this one let me change few things because here I have specified 2.2.2.2, but that's not 2.2.2 because the problem is I cannot use this source interface. What I'll do is I'll simply say for everyone, or you can be more specific, 100.0.20.2. That is the IP address. You can specify the mask, and that's an IP address. So you can see once I allow this, you can see I'm initiating a connection. We don't have the option of source here. That's the reason this is not going to work. So that's the reason I've added this. And once I do this, it's going to prompt me the password because already we have given the username. Username already mentioned at the time of connection. And it's going to ask me the password. The same thing, no difference here. Basically, you can see the same thing just like telnet. The only difference is it is more an encrypted connection. So this way you can verify if you have specific computers connected here somewhere. You can also use a PuTTY software or Secure CRT, whatever the console applications. You can also verify if you are doing in a real production networks. You can generally use a computers to log in remotely, either via telnet or SSH. So here in our lab, we are just using routers for the sake of verifications. But you can just go to the command prompt of your. You can go to your command prompt of your PCs, or you can use any telnet applications like telnet applications like PuTTY or Security Appliance software. Those applications also you can use.